Good morning, boys and girls.
Today we're going to do lesson 12-4, add fractions with denominators of 10 and 100. I can use equivalents to add fractions with denominators of 10 and 100.
So let's look at the solve and share. The mural is divided into 100 equal parts. Marilyn's class painted 3/10 of the mural, and Cal's class painted 27/100 of the mural. How much of the mural have the two classes painted? Ms. Schultz, what do we need to find here?
So we need to find how much of the mural the two classes painted all together.
Great. What do we know?
So we know that Marilyn's class painted 3/10 of the mural, and Cal's class painted 27/100 of the mural.
Okay, I'm just going to pull those two numbers out over here. So
Great.
how can we show what Marilyn's class painted on this hundreds grid that we have?
Okay, we can use place value blocks to represent 3/10. So I know I can use longs because they represent 10, 10, 20, 30. That represents 3/10. I also know by looking at the hundredths grid that 3/10 is the same as 30 hundredths, because if I were to use unit cubes, hundredths cubes, and I put 30 in, that would be the same as 3/10.
Perfect. Let's do Cal's class, 27/100.
So we can use unit cubes in groups of 10 for Cal's class. So 10, 20, 1, 22, 23, 24, 25, 26, and 27.
Perfect.
27 hundredths.
So how can we use what we know here to find out how much they painted all together?
So I know altogether is a key word, and it helps me identify the operation I need to use, which would be addition. So I know that I can add up all the parts that are painted on the mural to find out how much is painted all together.
Okay, so what could we count on this hundreds grid to get our answer?
We can count the shaded part of the hundreds grid to find out how much of the mural is painted by both classes. So we can count in groups of 10, or we can count individual squares, unit cubes, but I think it's easier to count by groups of 10.
Definitely.
So 10, 20, 30, 40, 50, and then I know there's 51, 52, 53, 54, 55, 56, 57. So there's 57 shaded units on the hundredths grid out of 100 units total.
So I'm going to use this 57 and just put it over 100. Can we write a sentence to show what 57 out of 100 represents?
Great. 57 hundredths of the mural has been painted.
So I'm just going to bring that down here. And there's our answer for the solve and share. Let's move on. Model with math. Write a problem that represents the addition shown below and then solve. So Ms. Schultz, in the first grid here, we have 10 boxes. How many of them are shaded?
So if I count the shaded parts of the first grid, it shows that 9 out of 10 are shaded. So 9/10 of the tens frame is shaded.
Great. In the next grid, I see that there's hundredths. So how many of those are shaded?
So I can count by groups of 10 in the hundredths grid to find out. So 10, 20, 30, 40, 50, 60, 70, and 1, so 71 hundredths.
Perfect. Can we add these two fractions together?
I don't think we can because we don't have the same denominators.
Wait, our Bitmojis have a message for us.
Oh, my Bitmoji says that you can use like denominators to add fractions.
And mine's telling us we can use equivalent fractions to write tenths as hundredths. So let's try this. We have 9 tenths. How do we get to 100?
We can rename 9 tenths as 100ths by multiplying 9 tenths by a whole number fraction that will give us a denominator of 100. And I know that 10 times 10 is 100, so I can multiply 9 tenths by 10 tenths.
Amazing. If we multiply it by 10 over 10, it's like we're multiplying it by 1. So we're not changing the fraction.
Nope, we're just making an equivalent fraction. And in this case, we're actually breaking 9 tenths up into 10 more parts so that we have 100 total parts. So whatever we do to the denominator, we also have to do to the numerator.
Great.
So we need to multiply 9 times 10,
which will give us
90 out of 100.
So then we can replace this 9 tenths over here with 90 over 100 and keep on our problem.
Yep, now we have 2 common denominators and we can add our numerators easily. Well, I know that 90 plus 71 is 161.
Our denominator stays the same, right?
Correct.
But this looks like an improper fraction.
Yeah, I'm noticing that the numerator is greater than the denominator, which tells me that this fraction is greater than 1 whole.
Okay. So how do we turn that into a mixed number?
So 1 whole in 161 hundredths would be 100 over 100, which equals 1 whole. So if we take away 100 from 161 and turn it into a whole number, we have 1 whole with 61 out of 100ths left.
Perfect.
So the answer to the addition problem is 1 and 61 hundredths.
Great. Let's move on to the next one.
Okay, 3 tenths plus 4 hundredths. Ms. Ortiz, again, I'm noticing that both our denominators are not equivalent.
So we must turn 3 tenths into hundredths. What can we multiply by to give us that hundredth denominator?
So again, we need to multiply by a fraction that's equal to 1. In this case, I know that 10 times 10 is 100, so I can multiply by 10 tenths. So 3 tenths times 10 tenths is going to give me 30 hundredths. So now I can replace 3 tenths with 30 hundredths, which I also know 3 tenths and 30 hundredths are the same. And I can add 30 hundredths plus 4 hundredths, which would equal 34 hundredths.
I'm going to put the answer back up here.
In the original problem. Great. So 3 tenths plus 4 hundredths equals 34 hundredths.
Perfect. Let's move on to the next one. 71 hundredths plus 5 tenths.
So again, we have 2 different denominators. I need to change 5 tenths into an equivalent fraction to hundredths. So I can multiply 5 tenths by a fraction equal to 1. Again, I'm going to use 10 tenths so I can get to a denominator of 100. 5 tenths times 10 tenths is going to give me 50 hundredths. So then now I can add 71 hundredths plus 50 tenths. I'm sorry, 51 hundredths, which will equal 121 over 100.
That looks like another improper fraction, Ms. Schultz. How can we turn that into a mixed number?
So I know that the whole here would be 100 over 100. So if I take away 100 from 121 and convert it to a whole, I'm going to get 1 with 21 left over out of 100. So 1 and 21/100 is our answer.
Perfect. There you have it. See you next time.